For this video, we are going to show the characteristic equation of this 2 by 2 matrix, which is important in identifying the correct eigenvalues together with their corresponding eigenvectors and ultimately the eigenspaces. Here, we are going to, of course, before we can come up with the equation, we are going to show the characteristic polynomial using this process here. We just simply need to come up with this form. You have lambda. We're going to come up with a matrix of lambda times I. Lambda is a variable in this case, times I, which is your identity matrix minus A. Once we are done with showing with the corresponding matrix of this, we are going to take the determinant of said matrix form. The determinant of the said matrix form is your characteristic polynomial. Equating it to 0, you will have your characteristic equation. Okay? Of course, in this case, lambda is again such a variable, but that's the goal later in separate video, as after the characteristic equation, we're going to move further in solving for the lambda, which stands for the eigenvalues. Notice here that we have I, as mentioned, that's our identity matrix. Our I here will depend on the type of matrix. We have a 2 by 2 matrix here. In short, your identity matrix should also be a 2 by 2 identity matrix. So let's start with letter A and let's try to specify the process here. Of course, this is just the lambda. And our identity matrix is 1, 0, 0, 1. Minus our first matrix A. Of course, we have two different matrices A here, but for the first, let's just simply use this one here. So you have 1, negative 3 halves, 1 half, and negative 1. So step by step, you will have lambda, that's the matrix, 0, 0, and lambda. Minus, again, you have 1, negative 3 halves, 1 half, and negative 1. So this would be the final form. Lambda minus 1, your first entry is lambda minus 1. Your second entry, 0 minus negative 3 halves, is positive 3 halves. Next, 0 minus 1 half. 0 minus 1 half, so you have negative 1 half. Then, to be followed with lambda minus negative 1, so you have lambda plus 1. Okay, this is now the matrix form using this expression. And the next thing here is to show or solve for a determinant in order for us to get the characteristic polynomial. The determinant for a 2 by 2 matrix is just simply the product of AD minus BC. So our A here is lambda minus 1 times lambda plus 1. That's our D minus B, which is 3 halves, times negative 1 half. Okay? Yeah, negative 1 half. That's correct. So you will have here the product lambda squared, of course, difference of two squares, minus 1. Okay? And then you will have here plus 3/4, right? So you have negative times negative is positive 3/4. So your characteristic polynomial is lambda squared minus 1/4, as it is negative 1 plus 3/4 or negative 4/4 plus 3/4. This is our characteristic polynomial. Equating this to 0, this is our characteristic equation. And again, this will be used to solve for the lambda as we move further in solving for our eigenvalues and so on and so forth. So since this is our task, so we stop here and let's do the same thing on our second, what do you call this one? Our matrix A. So this is, let's not put equality. So you'll have here lambda, and again, identity matrix 1, 0, 0, 1 minus A. So 1/4, 1/4, 1 half, and then 0. So you will have by matrix lambda 0, 0, lambda, that's 0, okay. And then you will have minus the same 1/4, 1/4, 1/2, and you will have here 0. So when we combine them, lambda minus 1/4, that's your first entry, 1/4. Okay. Your next entry, 0 minus 1/4. So you have negative 1/4. Let's make it a little bit farther. So negative 1/4. Then you will have 0 minus 1/2, so negative 1/2. And then 1, oh, yeah, here, sorry, not 1. You will have lambda minus 0, so you have lambda here. So from this, let's solve for the determinant of this expression or matrix. Again, it's AD minus BC. Your A is lambda minus 1/4 times lambda. Okay? And then minus the product of negative 1/4 and negative 1/2. So you will have here lambda squared minus 1/4 lambda, and then you have minus, because that's positive, then minus here, you have 1/8 here. So this is our characteristic polynomial, and then if you're going to equate it to 0, the lambda squared minus 1/4 lambda minus 1/8 equal to 0. This is our characteristic equation for the second matrix. So again, we simply use the determinant and then later on applied the necessary operations in order for us to come up with this expression here. So these are the processes in solving for the characteristic equation. We used this process to solve for the characteristic polynomial and equating said polynomial to 0 to get our characteristic equation. And this again are very important to in using or to move further in solving for the eigenvalues and eigenvectors and ultimately the eigenspaces. So this is all about the characteristic equation. Thank you very much for watching.